The muscle cells in our heart have the ability to last a lifetime. In fact, less than 50% of the cardiomyocytes in our heart will be renewed throughout our lifetime. This is both beautiful and problematic. The reason it's problematic is because cardiomyocytes do not self-replicate, so there is currently no source of cardiomyocytes. And this creates a pressing need to develop a way to manufacture these cells in the lab. Being able to manufacture cardiomyocytes would have enormous benefits for disease modeling, to be able to study diseases in the lab, but also potentially for cell therapy purposes, to be able to replace diseased cells after an injury. And currently, heart disease is the leading cause of death in the world, including in the United States, which again highlights the need for a supply of cardiomyocytes. For this, stem cells have two great properties. One, they can form any cell type, and two, they can divide indefinitely, so they can create a large supply of cells very rapidly. In our case, stem cells have a great potential to become a large source of cardiomyocytes. However, this approach has remained fairly unsuccessful so far. Stem cells are embryonic cells, so they're very immature, and forming cardiomyocytes from stem cells requires us to start from the very beginning. So far, stem cell-derived cardiomyocytes have only been able to reach levels of maturity which are seen in the cells of newborn babies, and they have never been able to reach full adult development, which is what would be necessary in most applications. So our goal is to try to recreate the cardiomyocyte's natural environment in the lab to be able to provide the cells with the necessary cues and triggers for them to fully mature. To do this, we work with hydrogels, or water-soluble polymers, which are commonly used in cell culture. These gels are a great fit for our application because they can easily be tailored, so we can manipulate the gel's properties so that they more closely resemble the cardiac environment. We also choose to combine lab experiments with machine learning models. This allows us to run through a large number of samples in the lab and then use our models to analyze the data and guide the optimization process of our gel properties. We hope that our gels will be able to support manufacturing of more adult-like cardiomyocytes, which could then be used for disease modeling or for cell therapy purposes. Thank you.